How you doing, guys? We're looking at slope functions here. So I'm going to just jump straight into some questions. For which of the following curves is the slope function, or dy dx, always positive? Well, if you look here, that's a negative slope, so it's not going to be the first one, okay? Any tangent line drawn there to the left-hand side at this point is negative. This one, that's a positive slope. In fact, every tangent line you might draw here has a positive slope. So dy dx is always going to be positive here. Over here, dy dx is always going to be negative. Any tangent line I draw will have a negative slope. Okay, so that's what they're asking about here. Okay, question 3. The graph of this function y equals f of x is shown on the right. Explain what is meant by f prime of x is greater than 0. That means that the slope of a tangent will be positive. So that occurs here and here and here, but it does not occur between -2 and 3. Okay, the slopes of tangents there are going to be negative. It does occur again for values of x greater than 3, 4, 5. There you get positive slopes. For what range of values is f prime of x positive? Well, that's going to be when x is less than -2. So that's all these x values here will have a positive slope associated with them. And when x is greater than 3, all of these values here of x have a positive slope, a tangent with a positive slope. For what range of values is f prime of x less than 0? Well, that is here, where the slope of the tangent is negative. Any tangent line you draw here would have a negative slope. So that's for values of x that are between 3 and -2. And then for what values of x is f prime of x equal to 0? Well, these are our local maximum points, and our local minimum are turning points. So x is -2 and x is 3 would be your 2 points there where that's less than 0. Equal 0, excuse me. Question 4, give 3 reasons why the given line represents the slope function of this curve. Okay, so first of all, for values of x less than -1, this says the slope of the tangent will be positive. So coming over here, is that true? Well, those are all positive slope tangents until you get to -1. Okay, so there's reason number 1. For values of x less than -1, the slope of the tangent is positive. At x equals -1, the slope of the tangent is 0. So that's the point -1, 0. It says when x is -1, the slope dy dx is 0. And that's true. Okay, that's our local maximum. And then for values of x greater than -1, our tangent slope is negative. dy dx is negative. Is that true? Well, greater than -1 here, all of these tangent slopes are negative. So yeah, that's spot on. Okay, I'll wrap up with 6. So short video. The graph of this function is shown on the right. That's a cubic function by the looks of it, and it's got 3 quadratics here. One of them represents the slope function. Which one? Explain your answer. So up as far as the point A, you've got positive slopes, and then at the point A, your slope is 0. Now that's true here and here. Slope is 0, and it's true here and here. Here, we don't have anywhere where the slope is equal to 0. So this couldn't be. It couldn't be C. Well, we said we need the slope to be positive for values of x up to A, and then 0. So that's here. Positive, 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 and then 0. Between A and B, our slope function will have a negative, our tangent will have a negative slope. Okay, so our slope function needs to be negative between A and B, which it is here. Our y values need to be negative, that is. And then beyond B, our slope is going to be positive again. So that point B, or that curve B, is our slope function. Okay, you might go now and do page 144, questions 2, 3. I know we did it, just I suppose fill in the answers again, maybe without looking at the video, see if you can do it yourself. And 5, which is similar enough to question 4 there. All right, thanks guys.